Welcome to Algebra 2. This is first semester's Chapter 3, Section 1 out of the Big Ideas textbook. And we are solving quadratics today. It says, how can you use the graph of an equation to determine the number of real solutions? Okay, we're going to solve three ways. We're going to solve by graphing, using square roots, and also by factoring. It says solve each equation by graphing. Grab your calculator. We are not going to do this by hand. Turn it on, get your y equals, plug that in there. We've got x squared minus x minus 6 equals 0. Press graph, and what you should see is a graph of a parabola that looks something like this. Now, the vertex isn't even the important part here. When we were in our unit on graphing parabolas, we said over and over again, find the vertex, find the vertex, find the vertex. But it's actually that intercept form with the p's and q's we care about, because we care about where it's crossing here. And it is crossing at x equals -2 and at x equals 3. And so those are our solutions, and we're done with that one. Now, over here on B, we have a problem. We've got to move that 4x over before we can plug it into the calculator to graph it. So we're going to have -2x squared minus 4x, because I had to subtract it to the other side, minus 2. Grab your calculator, go to y equals, clear out what we just put in there, and go ahead and type in this new equation. So we have -2x squared minus 4x minus 2. Press graph, and what you see is a graph like this. That means our solution is x equals -1. Now notice these graphs are different. For one of these, the first one, it crosses in 2 spots. For the second one, it's only crossing in 1 spot. And that's okay. We can have 2 solutions. We can have 1 solution. We can actually have no solutions at all. When would we have no solutions? Hopefully you're thinking when the graph doesn't cross the x-axis. Because what this is the intercept, the x-intercept of the x-axis is called a solution, or it's also called a zero. All right, let's do some more. It says solve by graphing. So calculator is on. I've got x squared minus 8x plus 12. Graph. And a quick sketch of this. I've got a 0 at x equals 2, and another one at 3, 4, 5, 6. So when I graphed it, it looked something like this. X equals 2 and x equals 6. All right, that's it, guys. Since we're not doing this by hand and we're just doing it in our calculator, that is really all there is to it. Go ahead and plug the next one in your calculator. Press graph. Pause me if you need to. This one looks like it's at 2, but I'm not quite sure. But what I can tell for sure is it's only crossing once. And so I'm going to go ahead and calculate the minimum value here. So now my calculator is asking me for left bounds and right bounds and guesses. And if you don't remember how to calculate the maximum and the minimum value, then you need to figure that out. You need to ask me. Okay, and sure enough, I am glad that I did that, because it is not 2. It looks like it's 2, But when I calculated it in my calculator, I'm getting the x is equal to 1.5. So in fact, the graph is like this. It just touches in the one spot, and then that's its turning point. It bounces off, and it's 1.5. Okay, now let's try number 3. I cannot plug this in the calculator until I move everything to one side. I'm going to change my size again. So I have 1/2 x squared minus 6x. I subtracted it over to the other side. Plus 20, I had to add that to the other side, equals 0. Into my calculator, I can put the 1 divided by 2 in parentheses for 1/2 x squared, or since I know that 1/2 is 0.5, I can go ahead and do 0.5 also. It doesn't matter. And bammo, guess what? That's not really quite what it looks like, is it? But the point is the same. It is a no solution because the graph is never going to touch. It's more like this, isn't it? Okay, no solution. And there is no solution because it never crosses the x-axis. I'll try to write solution better for you. No solution. That's better, isn't it? I guess I need to write slower. All right. Now, solve using square roots. If you look at this, we could graph it if we wanted to graph it, but it's almost easier not to. It says 4x squared minus 31 equals 49. Now there's only one x value here, or one term with an x value rather. So what I'm going to do is add the 31 to both sides, and I get 4x squared equals 80. Now what? I'm solving for x here. Divide by 4 and get x squared equals 20. Now I square root both sides. So x equals plus or minus square root of 20. You have to have the plus or minus here. And my best example for that is, like, let's say it's a 2. If it had been x squared equals 4, then x could be a 2, or x could be a negative 2, right? Because 2 times 2 is 4, but negative 2 times negative 2 is also 4. So you have to have the positive and the negative, plus or minus answer. Now, this answer, although it's lovely, is not done yet. You've got to go back to Algebra 2 in your, or not Algebra 2, Algebra 1 in your mind here and make those trees and break down that 20 because 20 is 4 times 5 and 4 is 2 times 2. So this answer is actually x equals plus or minus 2 radical 5. And that is our final answer, solving using square roots. Okay, let's try letter B here. It's 3x squared plus 9 equals 0. The first thing I do is subtract the 9 on both sides. And change my pen style again. I think my handwriting looks a little neater when I do that. Now I'm going to divide by 3. So I get x squared equals negative 9. Now, are you allowed to take the square root of a negative? right now, we haven't talked about complex numbers yet. So if you want to stop right here at this step and just say no solution, that is fine with me, because there is no real solution. All right, let's go ahead and look at letter C. First things first, we're trying to solve for x here, and there's a 2/5 out front. So I'm going to multiply everything by 5/2, because that will cancel the 2/5. That is called a reciprocal. Now this is a 5/1, and I want that to be neat, so I'm going to erase here. That's a 5/1. There we go, when I write slow. And this is a 5/2. Okay, so I have x plus 3 quantity squared equals 25/2. Now I can square root both sides. And I have to remember the plus or minus. So I'm going to get x plus 3 equals plus or minus square root of 25/2. Now we are going to do something with that because mathematically that's incorrect, but let's just continue the problem so we make sure you have the basic understanding of the skills here. We're going to subtract the 3 from both sides in order to solve for x. So I get x equals -3 plus or minus the square root of 25/2. Now let me get a different color and bring that 25/2 over here. The square root of 25/2 is the same as saying the square root of 25 over the square root of 2, which we all know is just 5 over the square root of 2. Now we're not allowed to have that square root of 2 in the denominator because it's an irrational number. So I multiply by the square root of 2 over the square root of 2. And what that does for me, I'm going to come down here, is 5 square root 2 over square root 4. But we all know what the square root of 4 is. The square root of 4 is 2, and so that is the simplified form. So I'm going to rewrite my answer. X equals -3 plus or minus 5 square root 2 over 2. And there I am. Okay, moving on. It says solve the equation using square roots. Just some more of these examples. So first things first, what we want to do is get that x alone by subtracting the 14. So go ahead and subtract the 14. From both sides, and you get 2/3 x squared equals 6. Get rid of the 2/3 by multiplying by 3/2. Remember that's a 6/1. So x squared equals, now I can say 18/2, which we all know is 9, if you want me to do that way. So x squared equals 9. And square root both sides, adding a plus or minus, and x is equal to plus or minus 3. Now let's look at this part again really quick. I had 6/1 times 3/2, and because it's multiplication, you're allowed to say that you know 2 goes into 6 3 times, in which case you would get 9 over 1, which is just the 9 we already had. So there's two ways of doing that. You can multiply straight across like we did, get 18 over 2 and reduce it, or you can reduce it in the middle of the problem as long as you're always reducing the top with something on the bottom. Okay, so plus or minus 3. All right, number 5, negative 2x squared plus 1 equals negative 6. Well, we have to start this by getting rid of that 1. So negative 2x squared equals negative 7. Divide by negative 2. Get x squared equals 7 halves. Square root both sides, remembering the plus or minus. And x is equal to plus or minus square root of 7 over 2. Okay, if you can get that far, you have shown that you have the understanding of how to solve a square root problem. But remember, we're not done because of the square root in the denominator, because this is really the square root of 7 over the square root of 2, which is not allowed. So I'm going to go ahead and multiply that by the square root of 2 over the square root of 2. Believe it or not, that's a 2. Got to remember to write slow here. So what I get then is the square root of 14 over the square root of 4. The square root of 4 we know is 2. So your answer should be the square root of 14 over 2. It's got a plus or minus in front of it. And it is an x value, so it should say x equals. All right, number 6, here we go. First things first, divide by 2. Get rid of that 2. So you have x minus 4 in quantity squared equals negative 5 halves. The next step is to square root both sides. And you can stop right there if you want to, because you've not learned complex numbers yet, and we're going to say nope, no real solutions here. That's not allowed. No real solution. Done. Okay, core concept. There's this thing called the zero product property. Basically, what it means is if you've got two numbers multiplying each other and they equal 0, so we have a times b equals 0, that means a has to be 0 or b has to be 0. That's what this means. So it says solve by factoring. Now it's kind of a rough one to start with because this 45 is over here. We need to move it over there. So we get x squared minus 4x minus 45. And solve by factoring. Well, factoring in this form here where we have a trinomial, it has 1, 2, 3, trinomial. We think what multiplies to make 45 and adds to make 4? So a 1 and a 45, 2 doesn't multiply, a 3 and a 15, 4 is not a factor, but 5 is, 5 and a 9, 6 isn't, 7 isn't, 8 isn't, 9 is with a 5, but we already have that, so we're done. Now you ask yourself, if you had the right symbols, if you had the right plus sign or minus sign, could you combine the numbers in order to make the negative 4? Well, a 1 and a 45 would combine to make either a 43 or a 46. A 3 and a 15 would combine to make a 12 or an 18. And a 5 and a 9 would combine either to make a 4 or to make a 23. I said 4, didn't I? Well, I want a negative 4. So how would I combine a 5 and a 9 to equal a negative 4? I would have to use a positive 5 and a negative 9. So that's exactly my answer. X plus 5 times quantity x minus 9. Now we can check that using foiling if you want. Foil. First is x squared. The outers are negative 9x. The inners are 5x plus 5x. And the last is negative 45. So x squared minus 4x minus 45, it checks. Okay, we're not done yet. It said solve using factoring, and they want us to use that zero product property. So what we do is we say, well, x plus 5 has to be 0, or x minus 9 has to be 0. So that means x equals negative 5, or x equals 9. Okay, let's try some more. Find the zeros. Okay, we've got a 12 here. So you're thinking, what multiplies to make a 12? A 1 and a 12, 2 and a 6, 3 and a 4, 4 and a 3. Oh, we already have a 3 and a 4, so we're done. Now, combine those looking for a 7. To combine a 1 and a 12, you would either get an 11 or a 13. So 11 or 13. Combining a 2 and a 6 would give you a 4 or an 8. And combining a 3 and a 4 would give you a 1 or a 7. Basically subtract and add. Alright, 7 is what I want, so that means 3 and 4 is our answer, but I want it to equal a negative 7, so that means it has to be a negative 3 and a negative 4. So we've got x minus 3, x minus 4 equals 0, so that means x, let's not skip, sorry, I was going to skip, I was going to get ahead of myself. Okay, so we have x minus 3 equals 0, and x minus 4 equals 0, so x equals 3, or x equals 4. Okay, let's try another one. It says solve by factoring and then find zeros. Okay, here we go. We've got a 35. So we're going to multiply to make a 35. We're going to add to make a 12. So I have a 1 and a 35. 2 is not a factor. 3 is not a factor. 4 is not a factor, but 5 is a factor. With 7, 6 is not a factor. And 7 is a factor with 5, but we already have it. Okay, this would give us a 34 or a 36 if we subtracted or if we added. And 5 and 7 would give us a 2 or a 12, and that's what I want. And I want them to add up to equal a positive 12, which means they both need to be plus signs. So I have x plus 5, and I have x plus 7. If I set that equal to 0, whoops, and I solve, I'm going to get x equals negative 5, or x equals negative 7. Alright, find the zeros of the function. Well, they didn't tell us we have to factor, but I can see, well, just by looking at it, factoring is going to be quick and easy because there's only 2. It's a binomial. There's only 2 terms here, an x squared and a negative 8x, and they both have an x in them. So if I factor out an x, I get x times the quantity x minus 8, and it's equal to 0, which means x equals 0, or x minus 8 equals 0. So x equals 0, or x equals 8. Moving on. Explain what method you would use and why. Why are we using it? Okay, look at A. You have x squared minus 84 equals 0. There's only one term here with an x in it. So this is ready to go using square roots. Alright, look at B. It's x squared plus 5x plus 4. You could graph this. You totally could. And, you know, graphing's great because you grab your calculator and it's done. So that's easy. But I can factor this in my head, already done, faster than you can even turn on your calculator. Because I know what multiplies to make a 4 and adds to make a 5 is a 4 and a 1. And I already have it done in my head using the factoring method. Now on letter C, this one is totally graphing because 1/5 x squared, I have no idea. That 1/5 fraction throws me completely off. So on letter B, you could graph if you really wanted to, but like I showed you, factoring was faster. It's done already. I already know x equals -4 and x equals -1. On letter C, where we get a little crazy there with the 1/5, nobody wants to play with that fraction. We're going to grab our calculator. All right, do some practice work. I hope you're having a great day.